Hello students, we are here with you to solve a trigonometry based problem. It is based on proofs where we have to use the trigonometric identities like sine square theta plus cos square theta is equal to 1, and we also have to use some reciprocal relationships like cosecant theta is the reciprocal of sine theta and secant theta is the reciprocal of cos theta. So here's the problem. We have to prove that sine A minus secant A whole square plus cos A minus cosecant A whole square is equal to 1 minus secant A cosecant A whole square. So how to go about this? What should be your thinking? What should be your approach? So normally we take one side and simplify it or um, solve it to in such a way that it gets to be equal to the other side, or we solve both sides and try to reach the same expression. So whichever way we may do, we have to choose which side to go with first. Now the side with which we start must be complex looking or bigger looking. And in this problem, you can see just the fact that on the left hand side is a bigger looking side may prompt us to take the left hand side. And that's what we are going to do here. We are going to take the left hand side, which is abbreviated as LHS. So now we should always be wary where we are going. We are to prove left hand side equal to right hand side, and on the right hand side is just the secant A and cosecant A, while on the left hand side, apart from secant A and cosecant A, there are sine A and cos A. And now we know that cosecant A is the reciprocal of sine A and cos A is the reciprocal of secant A. So we can change sine A and cos A into cosecant A and secant A respectively. Okay, let's change it. So sine A can be written as 1 over cosecant A. The rest of the things are going to remain the same. We are just going to copy, and cos A can be written as 1 over secant A. And now you can see that our left hand side has also been written in a way in which it also only contains secant A and cosecant A, nothing else. So we are now, our task is just to change the form so that it looks exactly like the right hand side. Now on the right hand side, we can clearly see that secant A and cosecant A are multiplied. So, and the present condition of the left hand side is that if we take cosecant A as the LCM, it, it will get multiplied with secant A, giving us the same sort of expression where 1 minus secant A into cosecant A is there. Okay. So we are, and similarly for the second expression also this is happening. Okay, so we should go by our intuition and do it. Okay, so let's do it. So we can say 1 minus secant A dot cosecant A whole square, and of course there is a denominator, and that denominator will become cosecant square A. And here again we will take secant A as the LCM, and the second term is going to become secant A dot cosecant A whole square and divided by secant square A. So we have kept the square only on the numerator, and distributed the square separately to the denominator. It was a whole square, mind you. Okay. So now you can see that the whole square on the numerator is common factor. So let's take it common, and it is also equal to the right hand side. So secant A plus secant A, the whole square factor. And what is left with us is, for the first term, it is cosecant square A, and for the second term it is secant square A. Now it is very clear that our task is now cut out. We have already got what we want on the right hand side, and we have got an extra factor. So this extra factor must be equal to 1. That's the only way left hand side is going to be equal to right hand side. So we are going to try and prove that this extra factor is indeed equal to 1. So 1 over cosecant square A, as I told you at the start, cosecant square A is the reciprocal of sine A, so it can be written as sine square A, and secant square A, like in the similar way, can be written as cos square A, and indeed it is equal to 1. So we are left with only the first multiplicand, 1 minus secant A cosecant A whole square only, because this is a trigonometric identity and it is equal to 1. So this is our right hand side. So we had started from left hand side and have proved it equal to right hand side. So that's the proof of this trigonometric identity. We could have gone the other way also, but that would be long way, changing secant A and cosecant A to sine A cos A. You can prove it like that too. But you will have to take both the sides and do a lot of steps. But this is the shortest way to do this question. I hope you get an idea from this question, and we'll be back with more such questions. Thank you.